Great. So thank you and welcome to the session Driving Efficiencies in IVF Upwards. Remember, all webinars are recorded, so you can revisit this webinar or others you might have missed from I3. Today, we'll be presenting 3 fantastic talks, and as these are presented, please remember writing in the question and answer section and not in the chat. We'll have time for questions and answers at the end of the 3rd presentation. Once again, welcome to the session Driving Efficiencies in IVF Upwards. My name is Alejandro Chavez-Badiola. It is a great honor to be co-moderating this session with my colleague, David Sable. David is a physician, made entrepreneur, working at the intersection of engineering and science in IVF, the miracle and magic of having children, and the mechanics of financing innovation. In other words, he has a hard job to identify brilliant ideas and to giving these ideas a chance to become a reality, and hopefully to help transforming this into a better world. David now directs healthcare and life science investing for Special Situations Funds, and is portfolio manager for the Special Situations Life Sciences Fund and Life Sciences Innovation Venture Capital Funds. Dr. Sable is an adjunct in the Department of Biology at Columbia. He serves on several boards and has written for several media, including Forbes. David, welcome and thank you.
Well, thank you, Alejandro, and thank you to I3 for letting me participate in this program. I've been a fan since the first one. One of the few things that's come out of COVID has been this forum, which is really, really powerful. And I think it's great to have a means of having people within our field get together from all over the world. I am honored to be here and to be co-hosting with Dr. Chavez-Badiola. He and I have gotten to know each other pretty well over the past couple of years. I've been doing a sort of a deep dive into the automation, the standardization, and the search for a common language within the IVF world, both for the purposes of stimulating entrepreneurship and, more importantly, to bring better care to patients. And the work that he has done in this area is really exemplary. It's complex. It pulls together disparate parts of patient care, engineering, science, and computer science. And it's been really heartening to see us move from, when I started doing this back in the late 1980s, we were doing clipboards and yellow stickies. And now the way we've grown with the information processing industry has been really, really terrific, and just paves the way for our future. So thank you, Alejandro, for letting me be your partner today. And now let's start. Remember, we're going to please ask questions using the Q&A section of the conference service, not the chat function of the of Zoom. And we'd like to move to our first speaker. Our first speaker in a talk is Matt Pettit, and this is a talk that is being sponsored from IMT International. Matt has an extensive background, laboratory work in human and animal embryology. Is responsible for the provision of cryopreservation systems in animal breeding, for development and implementation of Matcher, the advanced electronic witnessing quality management system for IVF clinics and donor banks. Background goes back to the University of Wales, R&D, Genus PLC in bovine and cattle breeding, bovine and equine sperm processing, sperm development, sperm study, moving to Australasia's largest standard bred ranch, Alabar bloodstock. Extensive work hands-on in product development and in quality control. Really looking forward to hearing Matt give his talk today. And welcome, Matt.
Thank you, Dr. Sable, and also Alejandro for moderating what promises to be an informative and stimulating meeting. Here's my declaration of interest, just to get that out of the way. I'm head of innovation and a senior product expert for IMT International, and we develop, manufacture, market, and distribute the Matcha electronic witnessing product for fertility centers and donor banks worldwide. I must also declare that the databases shown in this presentation are for demonstration purposes only and do not contain the names of any patients. Scientia Potentia est. No, not a spell from Harry Potter's Book of Wizardry, but a proverb, and it, like most proverbs it seems, can be attributed to a great 16th century English philosopher and statesman. Sir Francis Bacon argued for the possibility of scientific knowledge based only upon inductive reasoning and careful observation of actual events. Most importantly, though, he argued science could be achieved using a skeptical and methodical approach whereby scientists aim to avoid misleading themselves. Wise words indeed. The phrase scientia potentia est literally translates as knowledge is power, which has become somewhat of a cliche. But what does any of this have to do with IVF? Before I get around to answering this question, consider this. Most of us, I'm guessing, will drive a car. But I'm sure most of us will also agree that the vehicles we drive these days are far from simple. For the modern motorists, even relatively inexpensive cars do so much more than just get you from A to B. Satellite navigation systems, cruise control, they come fitted as standard. Climates controlled front and rear. They cleverly minimize fuel consumption and expurgate greenhouse gases. And if they didn't sync with your smart device, creating a microcosm of in-car entertainment, you'd be a mortally unhappy driver. But of all of the bells and whistles your car has, what's the one gadget that's mission critical? If you stripped away everything else, the one gizmo or app that you simply could not live without. In my opinion, it's the one that tells you how many miles or kilometers you can still drive before you run out of fuel. Or for our climate-conscious eco-warriors, it's the one that tells you your range before the short-life battery conks out. But why is miles to empty so vital? And why is it that we check our distance to empty dashboard probably more frequently than any of the other dashboards combined? I'll tell you why. It's vital because it answers a most important question for us. And the question is, will I be able to make it to the next fuel station before disaster strikes? As motorists, we all share this fear. If we run out of fuel or battery, this is our worst case scenario. But what I find interesting is this. If this feature simply expressed our fuel as a volume instead of a distance, or even as a gauge of the percentage of fuel left in the tank, would we pay so much attention to it? I doubt it. But as soon as that low fuel amber alert comes on, as sure as eggs is eggs, you're heading straight for the gas station. And just like our cars, fertility centers and donor banks are becoming more and more automated, and not before time, in my opinion. As most of us move away from the 16th century inhabited by Francis Bacon and into the 21st century, we've finally begun to realize that the use of manual paper-based systems for recording events, monitoring environments and apparatus statuses, witnessing procedures, tracking products and lots, and managing the cryostores is not only outdated and old-fashioned, it's time-consuming and therefore expensive, but also very risky in terms of staff and patient safety. Real-time and automated digital data capture is realistically the only way to input data in such a way that it can be used to reliably and quickly answer our most important questions. Humans make mistakes, machines do not. Well-developed ones at least do not. And assisted reproductive technology has evolved accordingly. We're by no means strangers to electronic and automated systems, which are already established in most fertility centers and donor banks. And after visiting hundreds of fertility centers around the world, I'm happy to report that at the very least, most centers have already chosen an electronic medical record system, or an EMR, and thankfully largely moved away from paper systems. But you also have electronic witnessing, computer-assisted sperm analysis, time-lapse, automated environmental monitoring systems to play with. Some of these are going to be demonstrated and discussed later. But have we ever really stopped to consider in depth why real-time electronic and automated data capture is so vital to the evolution of assisted reproduction services? Before we come on to this, we should first look at the different ways in which data that is being captured is outputted and how systems interface with the end users. There are a number of ways in which data captured could be beneficial to us as practitioners of IVF and also to our patients. And I'm going to present these as a cascade of benefits, with the least powerful at the top of the waterfall and the most powerful at the bottom. So firstly, information can be recorded directly at the workstation and in real time, which saves time and reduces transcription error. And this data can then be stored easily and safely for long periods of time. Digital systems can also continuously monitor an environment or a calibrated instrument, which is beneficial because they don't rely on a person to continuously check the apparatus. And if a parameter becomes threateningly high or low, or if something untoward happens, an alarm will draw immediate attention to the non-conformance. This, of course, assumes that someone's there to respond, which is why many systems will also send an alert to a phone these days. Proactive alerts are even more powerful because these inform a user if something is about to go wrong in advance of it actually going wrong. This is more like the low fuel warning, continuously polling KPIs. So for instance, a good electronic witnessing system will use pre-assigned labels that tell you if a mistake is about to happen before the gametes are actually transferred. Stock management systems should tell you if a product's running low before it actually runs out, and cryostorage consent alerts should also provide plenty of forewarning. Machine learning and AI is a hot topic at the moment, and potentially for enhancing processing and decision-making. Reports makes reviewing digital information easy to do and also very fast. But it's essentially how you subsequently analyze the data that makes the big difference between the knowledge being captured being useful and it becoming extremely powerful. The electronic system only really becomes powerful when they can answer the most important questions, the questions that, if answered correctly, can avoid catastrophe, underpin staff and patient safety, avoid wastage, and help to drive efficiencies and develop and promote best practice models. Remember the distance to empty dashboard. Let me now give you a few examples in the context of IVF treatment in the short time that I have left. By replacing the human witness, for example, with an electronic system for double checking the identity of gametes or embryos before each procedure is performed is extremely beneficial for several reasons. It provides an alert if you're about to make a mistake. It captures a large amount of data in one simple step, including who carried out the procedure, who was the patient involved, what was the procedure, where was the procedure performed, using what equipment and at what time, and it even takes a photograph as evidence. And more advanced electronic witnessing systems will even automatically capture the globally unique lot numbers and expiry dates of all consumable products and media that are coming into contact with the gametes and embryos as part of that same procedure. So these things are fast and they save time because you don't need two people or any manual entry. But probably the most important thing to remember, unlike humans, the electronic system cannot make a mistake. But why and what you do next with this data captured is the crucial element. What we really want to know is how many errors did we make today, or this week, or this month, or this year? So we need to filter by date range. And this will allow us to easily analyze this data and compare the equivalent data from yesterday, or last week, or last month, or this time last year, for instance. And we also need to know how many errors did each practitioner make during that period. And if there have been any near misses, when and where did those errors occur, and specifically during what procedure? We might also want to compare the error rate between users, for instance. This is another vital question to ask. And this helps to drive efficiency and identify areas that need addressing, such as urgent training requirements. So using this information, we can take the appropriate action steps to implement control measures to mitigate some of these risks. For instance, there might be a particular procedure that results in error occurring more frequently than others, which would suggest a process change or some other decisive action. And the one question I'm often asked is, can we export this data captured for further analysis or to compare the data sets to other centres in our group to help drive efficiencies further? And the answer, of course, is yes. Data that's captured electronically in real time makes this relatively easy. Something that would, however, be almost impossible in a manual or paper-based witnessing system. Being able to uniquely label individual samples in a freeze or a process such as biopsy with an electronic system is another good example of where electronic systems can easily outperform a human. But what do you really want to know? Why is using an electronic alternative to a manual handwritten process not just convenient, but vital? What you really want to be able to select is the fate of the individual embryos or gametes selected for transfer as soon as the quality has been assessed. So these samples ultimately end up being transferred to the right patient, or if they've been rejected, they're not transferred accidentally. These days, we're not just concerned that the correct patient identity matches anymore, but also that the uniquely labeled gametes and embryos, the ones that have been prioritized based on quality, such as embryo scoring or morphokinetics or PGTA, for instance, are also a match too. And another example, in the event of a product recall, it's not sufficient that we just know if a specified product lot has been opened and is in use. What we really want to know is whether the hazardous lot in question is still on our shelf, and if so, which shelf is it on, and has it ever been used in the treatment of a patient? And if so, which patients and cycles, and specifically in what procedures, and has it caused any deleterious outcomes? We need to know this information, and we actually need to know this information and access the information relatively quickly. I could give examples like this all day, but in the last example I'm going to mention before handing over to my esteemed colleagues relates to the time interval between two procedures in a process. As developers, we're often told about the potential importance of biological timings and the time taken to complete a process, and how long has an embryo been outside the incubator, for instance, and can we report out on these time intervals by analysing the data captured after the procedures have been performed? And the answer is yes, of course we can. We can query this out of the database relatively easily by selecting the start and the end points of the process in question. And there's your insight. But our question back is usually, but what do you really want to know? And why do you really want to know it? For instance, here we can compare the average times that 3 users took to complete a specific process over the course of a month. So in summary, by adopting electronic systems to capture data, we can provide important insights into the inner workings of our fertility centres and create simple, interactive and graphical interfaces that allow us to quickly and efficiently answer our most important questions, such as have we had any mismatches in the last 7 days or last month or this year? Has anybody overridden an expected procedure and done something out of the ordinary? Do we have any unresolved no matches in the clinic right now? Do we have any patients that have outstanding scheduled procedures that need to be completed today? Are we using any lots that have expired, or are there any lots of products that are due to expire in the near future? And do we need to reorder any products in the stock room? And also relating to cryo consent, do we have any freeze items, gametes or embryos under liquid nitrogen that are being stored illegally? Or do we have any items that are due to expire cryostorage consent in the near future? And how much available space do we have in our cryostores? All useful information. Hindsight is good, but insight is better. Capturing as much data as possible is always advisable and very useful, but we should try to define exactly why the data is useful, because this helps us to evaluate what data should be captured in the first place and how it should be analysed to provide useful and important insights. So that's a lot of data, but in a well-designed system, specific data sets can actually be queried relatively easily. These can be illustrated as tables or graphically, as we've seen, so that a summary of data can be reviewed at a glance and comparisons can be made. And with remote access to databases, Electronically captured information can easily be reviewed remotely across multiple databases, across several sites, even in real time, and on a variety of devices, including your smartphone. And if database service providers work together to integrate systems, we can potentially become even more powerful, because we can then potentially cross-reference the data captured from multiple databases for enhanced root cause analysis. As someone who's spent many years working on the lab bench, I'm looking forward to the day when we can quickly trap a downward trend in one of our key performance indicators, whether that's a drop in cleavage rates or blastocyst development or pregnancy rates or whatever it is, and refer to a simple dashboard that provides insight into the most likely root cause of the problem, and quickly. And these are the guys who can make it happen. I'm very privileged to be working with an extremely efficient team of software developers who strive every day to develop robust systems for exactly this. These are the guys, and many others like them, who have the knowledge and the power to tell us as practitioners of IVF our distance to empty. Thank you very much.
Matt, thank you very much. This was a fantastic presentation.
Thank you.
And before we move forward, I have one question for you. I always ask when I am overwhelmed with information if we're asking the right questions. And you presented in one of your last slides the names of many companies. What do you think that will be required for everyone to share the same language, computational language, the same interface, so we can allow for these companies to communicate, use big data, machine learning? What will it take?
Absolutely, yeah. It's probably not as a greater stride as you might think. The first thing it requires is cooperation. If the guys can work together and we all have the same vision and share the same goal, then actually integrating databases is probably easier than you think. That's what databases are designed for, after all. So using things like applications, programming interfaces, we don't really need to share a common language or a common interface. We can share data and output that data in the form of messages and simple calls to actions, so that we can share information between ourselves and present them in dashboards or other graphical interfaces similar to the ones that we've just displayed here. So actually, I think all of the companies that I had on that slide, for instance, are already working together to some extent to make this happen. So that there is a lot of work happening behind the scenes already, and long may that continue.
Well, thank you, Matt.
Thank you.
Now, I want to introduce our next presentation, staying in the driver's seat of your lab and moving forward, with Dr. Dimitri Consten. This is a presentation sponsored by Ciltrix. Dr. Dimitri Consten is a clinical embryologist and a lab manager at the Elizabeth II Hospital in Tilburg. He studied biology at the Utrecht University and received his PhD at the same university, working in the field of comparative endocrinology and developmental biology. After a postdoc research track at the Hubrecht Institute, he joined the IVF lab of the Elizabeth II Hospital in 2004. Since 2015, he is lab manager of the IVF lab. His main interests are quality control and embryo development. And so I leave you with Dimitri. Welcome.
Okay, the disclosure, well, I have nothing to disclose, but we use the Ciltrix monitoring system in our lab. And as I told you, and this presentation is sponsored by Ciltrix. If you are talking about the driver's seat, we always have to look back a bit. And where did we come from? Well, this is our lab in the early 80s as we started, with a few microscopes, a simple incubator, an old telephone, and just one simple small room. If you want to remain in the driver's seat, there's a couple of things you need to know. And one of the topics of a previous session was talking about key performance indicators. And this is necessary if you want to have some feeling about what's going on in your lab. For that, you have to check your database. You have to look at the results per year, month, week, per doctor, embryologist, or even per batch disposables and for the equipment. Another topic which was just previously published and discussed by the previous speaker is about safety, and we have to avoid mix-ups by double witnessing, which can either be by a second pair of eyes, which is manual witnessing, but moving forward, you can also do it by barcodes or RFID tag, which is electronic witnessing, and it all has to do with the safety for your gametes and your embryos, but also the culture media. An important factor for both is obviously temperature, carbon dioxide, oxygen, and the pH. And we have to maintain our gametes and our embryos at a constant temperature, and the same with the gases and the pH. But the same holds true if it comes to temperature and storage of culture media. How do we know and how do we do that? Well, first of all, how do we know that the embryos have been in a constant stable temperature, well, environment in total? And how much control do we need? There's a risk when trying to improve, but I will come back to that later. And we have to focus on balancing out the drive to improve efficiencies in the lab without losing control in the critical areas, like factors affecting the embryos and the information received from it. Okay, one way to know what's going on is, as mentioned already by the previous speaker, is either data registration or monitoring. However, the data registration is reactive and the monitoring is proactive. And one quote I found on the internet is about proactive being the same thing as being reactive. The only difference is that you do the reacting ahead of time. So proactive is better than reactive. Things to monitor in the lab. Well, we probably all know it, but it's about temperature, carbon dioxide, oxygen, but you can also look at humidity. You can monitor the display of your machines or even alarms generated by the machines itself. The way we do that is using, like I said, a monitoring system. And to work with that, we first have to define all the critical parameters. And then we obviously have to determine the critical range. As an example, we have here the temperature, which is basically set at 36.8. And the critical range is either 38 as the high range or 34 as the low range. And by doing this for all the equipment you have, I don't know if it's very good readable, but you end up with a description of your equipment and the adjustments you need to know. The temperature setting, the high level and the low level, and the time for response. Well, talking about the monitoring system and being a proactive monitoring system, what happens when the values fall out of the alarm limits? Obviously, the alarm system is activated, but what happens then? The alarm is transmitted to the users depending on the preferences of the user and depending on in or outside working hours, if you're in the lab or outside of the lab. And this is a graph from a refrigerator in a lab. You can see here are some door openings, which is quite normal, but in the end, it starts to deviate and deviate a lot. If we zoom in, you can see that there are several points where it exceeds the upper limit, and this will result in an alarm. The alarm is sent to the user either by telephone, text message, or email. And if there's no response, then the alarm is transmitted to the next in line, which is a safety method that there's always someone responding to the alarm. What it looks like on my telephone, for example, is like this. You get an alarm, it will tell you which machine it is, and it will tell you what is happening. So for example, here the temperature is 10.3 or 14.4. If we look in the monitoring system itself, you can easily see which machine it is, either by giving that it's giving a red bar, or you can even see it on a graph or a floor plan from your lab. basically telling you where the machine is that's going wrong. Talking about the efficiencies in your lab, our field of IVF is constantly moving forward, and this leads to more efficient techniques and more efficient equipment. As examples, we have, for example, like liquid nitrogen versus the vapor stage, and the more efficient time-lab incubators. And with the liquid nitrogen, you can see the old storage tanks, or you have the new vapor storage tanks. More information is available than before. You have the machine telling you if it's automatically filled or not, and what the levels are, and the temperatures are, and some other things that are generated by the machine. The opposite is true for the time-lapse incubators. You get some more restrictions and risk for the monitoring, basically because benchtop incubators will not allow for individual monitoring of gases inside each chamber because of space limitations, and also because of the regulations of the Medical Device Directive. If you have a machine, it's there and you can't change it. And also for the company, they can't change it unless they have to go through all the MDD regulations again. Basically, it's meaning that there's less information available than before with big old incubators, as you can see here. And some more restrictions and risks for monitoring are incubator humidity, the amount, quality, and type of oil, or even with the culture media. And this is summarized in this paper. Another problem with monitoring is the security that comes with it. If you look at remote monitoring, this can be done via an app or through a platform in your organization. But unfortunately, the world has changed when it comes to IT security. An app is easy access, but it's higher risk for hackers because it's more easily accessible for them. If you do it through a platform in your organization, it's a bit more elaborate, but because you first have to log into your organization, and then afterwards you can log into your monitoring system. It's a bit safer, but well, one thing that's very important if it comes to this is you have to check if your passwords are strong enough, and you have to change them regularly. And the other thing that can help you reduce the risk is the two-factor authentication, which is nowadays quite common. Going to the next subject, indeed a topic that is talked about a lot is artificial intelligence. And the question is, can artificial intelligence also be the future for monitoring? It's not as much artificial intelligence or deep learning, but what we need for this is drift analysis and anomaly detection. And this can lead to meaningful early alerting, which I will explain in a second. Another thing also discussed by the previous speaker is the use of metadata, which is combining information of different systems. For example, we have a system for monitoring, and we have a system for a database where it says how many patients are in which incubator. If you can combine them, you know, for example, if your incubator is in use or not when you get an alarm. Drift analysis is the analysis of a deviation from a stable situation. It will help you with the situation for early alerting, but it comes in different patterns. And there's a nice paper published about this pattern. You can have a sudden pattern, you can have an incremental pattern, gradual, recurring, and a blip, or the noise. The other way is the anomaly detection, which you need to tell you if there's a deviation or not. And any fool can tell a crisis when it arrives, but the real service to state is to detect it in embryo, as was told by Isaac Asimov. The anomaly detection is analysis of deviations of a normal pattern, and that can lead to meaningful early alerting, as you can show here, if you have a regular percentage temperature, CO2, whatever, you can see there's quite a range here, which neutralizes a bit here, but at the end, you can see there's a difference. This can be either an introduced setting by changing the temperature yourself, but it can also that something happened in your incubator or your refrigerator. And then it's nice to know that if there's an early deviation that can lead to an early warning, you know that you either have to replace or service your incubator. Okay, if you want to combine all this, obviously there's different systems and they come with different information. But we as professionals, I think it's very important for us to get in contact with your suppliers, bring them together and tell them what we need in the lab so they can combine the information and help you with indeed the metadata. My final considerations for this are a monitoring system can help you sleep at night. Be aware of restrictions that come with new technologies. Be proactive instead of reactive. And my last remark was, as lab professionals, we also determine the road ahead by telling our suppliers what we really need. I'd like to thank you all for your attention and wish you a pleasant continuation of this program. Thank you very much.
Oh, Dimitri, thank you. That was an outstanding presentation, as was Matt's beforehand. So I'd like to throw out, though, and we talk about quality monitoring, quality assurance. The systems that have been discussed so far monitor our processes and point out deviations from what we want the norm to be. If we look a little bit more broadly, think about airline pilots, think about people that run nuclear reactors, or children in school when the fire drill goes off. We practice constantly what the things that we do once the alarms alert us that there's a problem. And within the context of very well-designed, well-run, professionally managed embryology labs, do you think there's room for a best practices, including practice, what happens when the alarm goes off?
Oh, I certainly think there is. I mean, it's always nice to know by heart or by routine what you should do when there's an alarm coming or alarm causing a disturbance. And certainly drilling your people and so informing them what to do and learning them how to deal with it is very important. So it's not just the alarm and responding to the alarm, but also knowing in advance what to do with the alarm through all layers of your organization. And obviously, one thing is responding to it, but the best way is, and hopefully not deep learning, but the analysis we talked about and the preventing of these errors and these alarms, telling you in advance that they might occur can help you prevent a lot of these situations.
Well, outstanding work, and as the field continues to expand in the number of procedures and specimens we deal with, it's great that we've got this kind of mechanized standard to back us up on. Well, thank you, Dimitri. That was outstanding.
Thank you.
Our next talk, we've had two outstanding ones, and I'm sure our third will be as well. I want to introduce Unika Alexandra from Northwell Health Fertility. Unika is a product of the biomedical science in embryology and andrology from Eastern Virginia Medical School, a legendary place within fertility in the United States. She's a clinical laboratory scientist licensed by ASCP with 10 years of experience in reproductive medicine. Previously worked at California Cryobank as a branch manager, laboratory operations manager, and tissue bank director, but currently working with the really outstanding fertility unit, Northwell Health, as the clinical laboratory operations manager. Let's welcome Unika Alexandra. Unika, thank you for joining us.
Thank you very much, Dr. Sable, for the introduction, and thank you so much to I3 for the opportunity. I'm using the applications that I'm about to speak about, but I have no other disclosures. So in our facility, we utilize several different applications in order to manage data. Our IVF team uses Media Lab, Reflections, Fertility Connect, Sotrix, INT Matcher, Engaged MD, and FERT for data entry and aggregation. For the purpose of this conversation, I'm going to speak about Media Lab, Reflections, and Fertility Connect. Zotrix has already been covered, as well as IMT Matcher. So as our team members use these apps for data entry, we as management use these apps for data review and audit. The first app that I'm going to speak about is Media Lab. So what is it? Media Lab is a cloud-based application for document control, and there we're able to manage our policies, SOPs, forms, and schematics. What does Media Lab do? So it is an automated, centralized platform for document creation, approval, workflows, revisions, sign-off, and audits. And it is flexible, which allows it to be customized to our institution. So at Northwell Health Fertility, the primary benefit of Media Lab is that there are no more shared drives, no more circulating documents with different versions, and no more documents sitting on desktops. So this software allows us to approve our SOPs electronically before implementation. It allows us to house our embryology, andrology, and endocrinology manuals in electronic format in one place. We also use Media Lab to house our consent manuals, our workflow manuals, as well as our quality management system manuals. So all documents that are in Media Lab have control numbers. We do have the option of assigning control numbers to these documents ourselves or allowing the system to assign them for us. Any document that is in the system has a major and a minor version. A major version simply means that a lab director has to approve the document before it is ready to be used. A minor version just means that it could be edited and it could be used immediately. So Media Lab has the benefit of electronic notifications for performing employees. So as a document is approved by a laboratory director, an email notification will be sent to any employees who are assigned to that document, letting them know that it is time to review the document. As management, I'm able to see what employees have and have not signed off on these documents through email notifications as well. Another added benefit is that any document that is printed from the document control application is printed with a watermark that says uncontrolled. So if someone was to save a copy of that document on their desktop, it really is a read-only document. It can't be distributed in that sense of the word. Media Lab allows us to provide inspectors with special permissions. That way, if we do have an inspection, we do not have to print out 100 pages of a particular manual. So here is a screenshot of what the Media Lab dashboard would look like. I want to draw your attention to the search option here. This is really convenient because what it does is that it allows the user to search for any document based on the title or based on the content of the document. So if you're at the bench and you need to find something in a document, you do not have to go through multiple pieces of paper or find the document and try to find where that particular context is that you're looking for. If you look towards the lower left of the screen, you'll see that our manuals are here. And if I was able to click on these to show you, you would see that as we open up each of these manuals, the content is in there. Another item that I want to point your attention to is the upper left, where we have a report option here. As management, you could really go in to see which employees have and have not signed off on documents that need to be signed off on. You could see how long an employee took to sign off on a document. So if someone kind of really glanced at a 10-page document, you'll see that they took, an hour opposed to something that might take a day or two to review. So that's really helpful to understand how your employees are working with these documents. So the other application that I'm going to speak about is Reflections app. And we use Reflections for quality control. So Reflections is a cloud-based application, and it provides flexibility for us to manage our quality control. It allows us to manage our data, reporting, and analysis. It is easy to interpret, and with electronic access from any internet-connected device, a tablet, a phone, an iPad, managers and supervisors really have the option to go in at their leisure to understand how QC is going on in their laboratory. Reflections has the added benefit of summary reports, whereby on a monthly basis, our laboratory director does need to review our quality control, and review can be done electronically. So there is no need to print out any paper from the Reflections app. The signature is saved in the app and reviews done electronically. Another really good benefit of Reflections app is the alerts. So if anything is out of range, an email alert or text alert can be sent. And if QC isn't performed by a particular time, an email or text alert can be sent to management to let us know that QC is not completed. So I will continue going with what Reflections app does. So like I mentioned before, it is fully customizable and is used to track QC data. To use the app, we really create instruments, and I put instruments here like this because anything could be considered an instrument with this app, which is really helpful. So we would put in a refrigerator temperature for quality control as an instrument. However, we could just as easily put in decontamination as an instrument. That way we could use the app for things outside of the core context of what we consider an instrument. If we're supposed to QC, if we have 10 instruments that we need to QC in a particular day, what the app has the benefit of allowing us to do is to create log plans for these instruments. And that's really grouping these instruments together. So on a particular day, you don't have to select these 10 instruments for each day, 7 days out of the week. You simply select a log plan and you use that for your day. The log plans are able to be modified in real time. So if something needs to be added to the log plan, it could simply be done in real time. If someone needs to remove something from the log plan, that could be done as well. And any employee with the proper authorization can enter data into a log plan. So one employee selects the plan and numerous employees could enter data in the laboratory. So at Northwell Health, the primary benefit of Reflections app is that we do not use clipboards anymore. We do not use paper QC anymore. And this is used throughout our embryology, our andrology, and our endocrinology laboratory. We are fortunate enough to have iPads that we use. However, a phone, a computer, laptop, basically any internet connected device will allow you to use this app. We do have our daily, weekly, monthly QC plans saved in the app, as well as our startup and shutdown checklist. So Reflections does give fluctuation reports for troubleshooting and trend analysis, and we're able to see and document any corrective action that needs to be documented directly in the app. So I just want to point your attention to just a few images from the app. What we're looking at right now is an example of instruments that have been entered into the app. This is from our embryology laboratory. It says right here on the left, this is just a list of instruments. This slide is an example of log plans. So as you enter the dashboard, the first thing you're going to see is a list of log plans. You notice that each of these plans have different days. This is actually from our andrology laboratory. And as you click on view, you would see all the different instruments in there that have been QC'd for that particular day. Right here, we're looking at a fluctuation report, and this report really allows you to select a particular instrument to view QC in a different way. Opposed to looking at the raw data, you could see a fluctuation report which shows the mean as well as the standard deviations and a probability density. So this is really helpful. Another really good thing about the fluctuation report is that you're able to select the date range that you want to look at, and if you need to change the instrument on a fluctuation report, you don't have to go back in and out of the report. You simply, from this screen, just select a different instrument. And what's not depicted a little further down the page is that the raw data for that particular fluctuation report timeframe is viewable in the same screen. Here is an example of a comment log. So any comments that are made for any particular reason, including corrective action, could be viewed from this log. So the comment log shows the date that the comment was made, the individual who commented. You'll see that I commented on something on April 16th. Morphology QC, and it also shows exactly what instrument the comment was made for, and this is really helpful in terms of reviewing data on a whatever basis we need to review it on. So the next app that I'm going to speak about is Fertility Connect. So Fertility Connect is a suite of operational applications for fertility programs, and it has been developed by Health Connect algorithm. It is accessed through our browser, and it has really allowed us to streamline our clinical, administrative, and laboratory processes, including logistics, scheduling, and patient workflow. So what does Fertility Connect do? The suite offers a collaboration portal. It has tools to allow us to improve our internal communication and efficiency, to connect to organizations across locations, because we do have another fertility center in another part of New York, and it encourages information sharing. So at Northwell Health, Fertility Connect helps with interdepartmental coordination. So we have eliminated, for the most part, back and forth emails between our clinical, our laboratory, and our billing teams for different aspects of patient care. One example is to confirm that all the necessary prerequisites have been achieved for a cycle start. If billing has a particular prerequisite that the laboratory needs to know before they're able to schedule something, the minute billing puts in their information in Fertility Connect, the laboratory gets an automated email notification saying that that prerequisite has been fulfilled. So that is very helpful. Another aspect of Fertility Connect that is helpful is scheduling. So Fertility Connect has, it acts as a central hub to schedule our andrology procedures, our IVF, and our IUI cycle starts. So I want to point out that for our IVF cycle starts, one really beneficial aspect of Fertility Connect is that it allows our coordinator who does need to enter start data to see exactly when a cycle has started. That way she does have a 3-day time frame in which to enter start data. So it really has helped with workflow in that respect. The other thing about Fertility Connect is that it acts as a central hub for our internal and external links. So all of the apps that I've spoken about today, Reflections, Media Lab, Ziltrix, our EMR, LIS system, all of this is housed in Fertility Connect. That way our staff do not have to save links onto their desktop or bookmark links. It's just all in Fertility Connect. So I want to point out just an example of our laboratory management workflow. You will see that the very top of our workflow starts with Fertility Connect. As information is entered for a cycle series, the laboratory operations coordinator knows that that information has been entered because automated messages are sent, and they're able to coordinate whatever needs to be coordinated moving forward, which includes start data being entered. So what we're looking at here is a dashboard from Fertility Connect. You'll see that on the left where it says links, this is all the links that we use as a center, it's all housed in Fertility Connect. So like I said, we don't have to find these links on our desktop. Another aspect of Fertility Connect that is really helpful is we house consents in here. We do use Engaged MD for consents. However, should someone need it outside of the system, Fertility Connect is able to provide access to the consents that are needed. So the benefits of electronic applications. So all of these applications have a common theme. They increase the efficiency of aggregating, communicating, and reviewing data. They all have real-time email and text notifications, which is a huge benefit for efficiency and for staying on top of what needs to be known in our IVF lab. Data review and analysis as needed for problem solving is at the tip of our fingers with all of these electronic applications, and we're also able to access them during specified periods of review based on our quality management system. Retrieving documents for regulatory audits without sorting through binders is a huge benefit now that a lot of inspectors are allowing us to present information electronically opposed to printing it out on paper. And we're able to meet the regulatory requirements for record retention electronically, which reduces the need for on-site and off-site storage, as well as allowing us to save a few trees. So I believe that moving forward, automation in the form of electronic applications will help us standardize and increase the quality in our IVF labs. I do believe that the future is inevitable and the future is now, and we all need to get on board. Thank you.
Well, very good presentation, Unika. Thank you very much. I'm completely biased. Probably I have used Reflections for very, very long, and I love it. And I will always remember, probably it was 2-3 weeks into using it. I landed in New York, 7 a.m., and I received an email, very concerning otherwise, because there was a problem in the lab. Called immediately, and my lab director was already there solving the problem. No more paper. I really, really like it. But I have a question for you. Just thinking of all that's been said between the difference of being reactive against being proactive and the advantages of becoming proactive. In my experience, when there is a huge overload in the IVF lab, then results tend to become poor. So how close do you think that we are to becoming proactive with these systems that can actually proactively help us to manage the workflow in the lab? This is to anticipate when you're getting too many patients to be triggered for a collection on Friday, and to help us proactively to reduce the workflow with anticipation.
Yeah, I do think this all ties into being notified in a proactive way opposed to a reactive way. I believe that almost all the applications that we use does give real-time notifications. So as these applications become more accepted in clinics, utilized for scheduling and utilized for inventory, I do think that we're not far away from getting to the point where we could make these decisions before we end up in a situation where we shouldn't be in terms of workload and patient scheduling.
Thank you very much, Unika. So, David, I believe that we had 3 excellent presentations. And to put the cherry on top of the ice cream, would you mind sharing your closing remarks with us?
Oh, thank you. And I agree. The presentations were outstanding. Thank you to Matt, Dimitri, and Nika. Very illuminating, and it's taken together. They paint a really good picture of a field that is really doing a great job of engineering the increased demands that we have as in IVF. Want to share my slides here. I've got a couple of brief remarks. I'll keep it short. I want to leave plenty of time for questions because frankly, the questions are a lot more important anything I have to say. These are my disclosures. Yeah, I was told once that I have so many potential conflicts. It's like I have no conflicts, but I won't be mentioning anything of a commercial sense. I do need to make an SEC disclosure, believe it or not, explicitly say that I am not raising money for a fund, and I'm not recommending anybody buy stock in a company during this presentation. Next. Now, I am old enough to have been around when IVF was a very under one roof, and nothing really moved around very much. Every specimen that was generated stayed put. It lasted for about one cycle, then it was gone. You know, when I first started doing IVF, late 1980s, about the only thing that we froze and stored was occasional sperm sample. You can see we've all lived through, we all entered this list at some point where we started storing embryos in a low implantation era when we were using most of them fresh. And then we went to a single embryo transfer era. Now we're storing oocytes and tissue samples of various types. And this number is only going to increase. Every one of you knows more than I do from your extensive experience in the lab the past, really since 2012, just the proliferation of specimen accumulation. And this one thing by itself kind of redirects our attention from the really excellent presentations we've seen so far, which is quality assurance, quality management on site in an individual site, to what are the things that we can do as a field in general to kind of facilitate the scaling up of the field, to facilitate the emergence of a best practice, and to, in spite of the stresses that greater throughput will put into an aggregate system like the world's IVF labs, in spite of that increased throughput, how do we make them safer and safer so that the errors that show up once in a while don't start multiplying, and we don't start seeing faults in the system itself? I started restudying IVF in 2012. I saw my last patient in 2004. And we did, over the years, then a fairly detailed input-output analysis of the field itself. Now, you don't have to see all this. This is a slide that I use just kind of to give a general overview of kind of the ecosystem that patients go through. And it used to be very simple. It used to be the patient was by herself, and then she went to her OBGYN, and then she went to an IVF clinic. Samples and specimens and records tended to live in one place and not to move around all that much. As we've gone to a more complex ecosystem, the patient is generating an awful lot of information herself, sometimes even generating specimens that get sent off to a laboratory. The patient OBGYN interface, as is a much more complex one previously than it was. We've introduced genetic analysis in. We've introduced much more analysis of the family itself. In the future, we may see some of the procedures that are done under one roof in an IVF clinic start migrating back into specialized areas of OBGYN clinics. We're seeing the emergence of centralized cryostorage. And we're also seeing a dissociation of the IVF center into a clinical center and a laboratory center. So really 5 separate geographies or categories of geography with much movement back and forth of specimens from one place to another, having different procedures done. Sometimes the specimen will be split into multiple specimens. Each of these little interactions, each time something moves along one of these curved arrows, is an opportunity for a potential error. And a system that is adequate to handle 2.5, 3.5, 4 million cycles a year may get very badly strained and start breaking when we go to the 10 or 20 or 30 million IVF cycles that in some of my more boring weekends I've modeled out the potential world demand for IVF to be. So how do we go about and start managing this? Well, this is not the glamorous part of innovation. This is where we as a field kind of collectively say, you know, in addition to the coding, in addition to the robotics, in addition to the AI and the machine learning, someone's got to build drainage ditches. And as we do our innovation program to program and optimize our practices and define best practices under our own roofs, how do we make sure that the field as a whole keeps itself safe? Now, I just want to address one aspect of that. The use of unique identifiers is something that we encounter all the time. Social Security numbers have been around since 1936. VIN numbers on automobiles, very specific. It's like you don't have the you don't have a 2012 Lexus. You've got a long VIN number, maybe with a barcode attached to it. So you know specifically where this automobile has been. ISBN numbers for books. We've been scanning groceries since 1974 here in the United States. Good way of tracking, tracking produce, tracking food safety, making sure that we know what field something came from, how it was shipped to the various markets where it could be sold. So if someone in New Jersey gets sick by eating a contaminated lettuce, we can figure out all the way where it came from and how it got to where it was sold, so we can proactively protect our food supply. To date, we don't have anything like that for oocytes, embryos, sperm samples, and the biopsies that we create within our infrastructure. So as we expand IVF, as we grow IVF, as we want to ensure the highest possible quality to the greatest number of people, both to treat our traditional constituency, those who have refractory infertility, and those with habitual pregnancy loss. And we use IVF to facilitate proactive family management, whether it's just mitigating the risk of not being ready to have children at your peak reproductive ages, or the fields of things like oncofertility, where we want to offer reflexively any young person who has to undergo sterilizing cancer treatment. We want to make sure there's a system there that can retrieve their eggs, preserve their fertility, and yet make sure that those eggs are protected as much as possible. Now, a lot of this comes from the private sector, and being a venal, greedy, horrible venture capitalist, that's where I spend most of my time. On the same hand, we want to, as a field, kind of ensure that we get the little things right too. Now, there's an organization I'm peripherally associated with called IVF Open, which is aiming at this specific problem itself. And we're working with IBM's blockchain group to create a single source for every time you create a specimen. Right now, you create a specimen, you put a label of some sort on it. That label will have some degree of information on it. The likelihood of any two specimens ending up in a lab later on with the same label is pretty low. But as we get from the tens of thousands, hundreds of thousands, millions to tens of millions of specimens, traveling sometimes 3, 4, 5 different sites, these become real problems. So we're trying to create a system that just, if you create a number, we give you the number. We just finding a way to make it easy to get that number, make sure that as your centers grow, we know that in China we have IVF centers that under one roof are doing 40 to 50,000 IVF cycles in one place per year. That's not the peak. We're going to be seeing lots more larger places. We want to be able to track our IVF reproductive medicine specimens the same way we can track books, cars, or produce as it goes through the sample, through the system. Now, just an idea I wanted to throw out that I've been looking for great ideas within the IVF engineering ecosystem. They're all over the place. This is a very, very exciting field. But one of our challenges, both to ourselves, to make our jobs easier to do, certainly to our patients, to whom we want to make sure that the never errors of specimen loss or specimen misidentification don't occur. And also, just practically speaking, there has been no rapidly growing area within healthcare, anywhere within the developed world and most of the world, the developing world as well, that doesn't ultimately attract greater amounts of regulation. It's a lot easier to control the regulation if you proactively get to work on it than to wait for something bad to happen and have the public sector decide, coming in from the outside with limited knowledge about how your industry works, to come in and say they're going to enforce regulation on top of you. So I'm going to stop there. I think it's much more important that we get to everyone's questions. Again, 3 terrific talks today, and let's go to our Q&A.
Yeah, David, thank you very much. I really enjoyed this wrap up, and the first time that I heard about this international global BAI and number for embryos and gametes, I loved it. So let's hope that this gets implemented soon. So a lot of questions, some very, very interesting ones. And I would like to start with a question for Unika. Philip Chan from California asks, what is your clinic backup protocol in the event that the Medi Lab Cloud internet is not accessible or has been hacked? Does the system or your facility back up the data?
So our document control is backed up. The system that we use does allow us on a regular interval to back that up. So what we do is we simply load everything onto a flash drive. That way it's in a format that we could transport. And should anything go down with the computer, with the internet, we are able to retrieve that on a different computer without having to log onto the internet.
Okay. And another question around security. This question for Dimitri. You mentioned hackers. Is it really a problem in clinics? And question for everyone.
Well, to start off, I'm not an IT expert. Let's start with that. But what I've understood is from the people that are working in the field of IT and collaborate with IVF, that apparently some IVF clinics already have problems with hackers, and it will be very bad if you have a monitoring system and someone can access it and change all your parameters, so you end up with not getting an alarm when you're supposed to get an alarm. So I think it's something that is definitely serious, but like I said, I'm not an IT expert, so I don't know how big it is.
We're actually fortunate to have Michael Scumio here, who is an IT expert, and I'm hoping that Michael could answer the multiple questions about the security issues, cloud-based applications, hackers, etc. You're on mute, Michael.
Thank you, Mia. Hi all, I'm Michael Scumio. So data security issues, especially significant to IVF laboratories, where it presents an enormous liability. We know that over 1,000 healthcare organizations have experienced security breaches recently, causing overwhelming amounts of protected health data to be compromised. And this actually includes recently a US fertility, which is one of the largest networks of fertility clinics in the United States. They actually confirmed it, that they were hit by a ransomware attack and the data was actually stolen. So with everything else, it's best to avoid problems before they start, especially with security breaches. And with cloud-based or on-site servers, there are certain steps you can take to protect your data and equipment. And in general, these are performing risk assessments and reviewing logs on a regular basis, hardening your IT infrastructure, the networks and applications. Data encryption is especially important. So encrypt your data at rest as well as in transit. Disaster recovery policies certainly key, making sure that you have automatic, daily backups and actually testing those backups and that they do work, because at some point you can kind of assume you have a policy and a backup running, and it turns out that backup actually didn't run. Ensuring your staff is properly trained. So training your staff is absolutely key, to be aware of spam emails, of different types of hacking, how to utilize applications and systems. So staff training is certainly key. Keeping software up to date is very important. That goes for the operating system as well as the actual software that you use. Controlling access to protect patient data, such as offboarding and onboarding employees, and making sure access is provided and only access required to perform your responsibility, and no more or no less than that. And then also implementing a password policy to make sure you have a good, strong password is key as well. So those are some of the things. Hopefully that kind of answers some of the questions. And if there are any more questions about that, I'm happy to provide more details.
Thank you, Michael.
Thank you.
Excellent. We've broken all the rules of being good hosts by letting Dr. Mina Alakhani show up on screen without properly introducing her. So let's welcome Mina. Everyone knows Mina very well, but welcome, Mina.
Thank you, Dave. Thank you.
One of our world's famous and my own most favorite embryologist. Next question is for Matt. Matt, why stickers? That seems like we've been talking about such great technology, and then we bring in stickers, which seems so 1960s. Can we do better? And I'm sure you probably have thoughts as to what would be better.
Yeah, it's a good question. Thanks, David. But barcoded labels may seem simple and old-fashioned, but they were a fantastic invention, US invention, of course, since their introduction, as you said, in 1974. They actually remain a force to be reckoned with, and they're actually very hard to beat for several reasons. So firstly, on a barcoded sticker, you can display the eye-readable and the machine-readable text on a single label, and really go down to very tiny labels, including those small enough for probably the smallest would be the vitrification devices or the 0.2 mil PCR tubes. But this really creates that fantastic link between the human and the digital world. So you've got the eye-readable text and the machine-readable text. And then the other great thing about barcodes, as you said, David, I think your vision is terrific, that it is possible quite easily to make them globally unique. So even in our system, every label that's produced, not just for the patients, but every single specimen label is globally unique and globally identifiable. They can be produced at the point of knowing what specimens you have for long-term storage, and they can be applied accordingly. And then using those barcoded labels, that can be used to uniquely track the samples through the system, including verifying, as we said in the presentation, the correct transfer of the correct specimens, not just the correct patients, but the right specimens. I think there's a very good reason why supermarkets, despite 50 years of development, still choose to use barcodes and sticky labels, even after 50 years. However, as developers, we are keeping a very close eye on what's out there and what is being developed and what we can develop ourselves. It's quite interesting, in Europe, there has been recently the introduction of a single European code, which is a drive towards global standardization. Most manufacturers are also using GS1 barcodes, which are global standards for being able to uniquely identify products. Everything links together very neatly indeed. So for the time being, we're sticking with the humble barcode, but we're very keen to see what's going to be developed in the future and modify our systems accordingly. But right now, barcode is king.
Outstanding. I guess we go far enough into the future, and every specimen just carries its DNA as its identifier. But yeah. We need the rapid reader there. Nika, question for you. A new embryologist comes in and you're onboarding them. How long is the learning curve for the system that you described earlier?
So I will direct that question to Dr. Alakani because she is the expert at onboarding new embryologists. I am more into the andrology, endocrinology aspect of it. So Dr. Alakani, you take it away.
Thank you, Nick. I think thank you, but you know, learning each of these platforms is not really too difficult. They all get some getting used to. You know, you have to get used to using them. And depending on how computer savvy, I guess you are, it may take a little bit longer, a little bit shorter, but I don't see that as a major issue. What I see as an issue, and we still battle with this, is duplication of work across these various platforms sometimes. And that includes, for example, IMT Matcher. Okay, IMT Matcher, you know, it has amazing capabilities, you know, to keep cryo storage data, to keep data on lot numbers, etc., etc., etc. But we're also inputting all of this information in 5 other places. And so to me, it's the integration of these various platforms that really is the key to eventually standardizing everything and really reaching a very highly efficient status. And that is the sort of the challenge we are facing now, not individually training people to use one or the other platform. They learn that pretty quickly. They're not too complicated. Most are very user-friendly.
Yeah. And I do want to mention that most of the applications that we use, we do have vendors who are willing to come in to assist with training, so it's not left up to management to perform training for these individual platforms in the entirety of, you know, training.
Yeah, and I think with regards to integration, Mina, also, yes, I think we certainly share that view as well. What we're really trying to avoid is duplication of information to drive efficiencies, save time and cost. There is an ability to be able to share data. I think we need to decide where the data is best to be captured, and then where the data is best to be saved in what repository, and then how to actually access that data retrospectively for insights or root cause analysis or whatever it is that you want. So to develop seamless systems like that does require quite a large level of integration. So, and if people are prepared to cooperate, if service providers and end users are prepared to cooperate, then it's definitely possible. We've demonstrated that with a number of examples. One in Denmark, for instance, Cryos is now linking several applications together to create one seamless workflow through their entire system of collecting donor samples, through to labeling, through to storage, through to populating the relevant fields in their EMR systems with that data. But so it's all about design, cooperation, and implementation, but it's definitely a lot easier with digital systems compared to paper-based systems.
Absolutely, yeah.
Well, now that you mention the digital systems against the analog systems, there are a couple of questions around this. The first one, do we need both cell phones and analog phone lines to send out alarms and alerts nowadays, both coverage and also for redundancy? And
yeah, the question.
And if you don't mind, I'll ask the next question, because again, is a contrast between the new and old, and I think that many might be sharing these potential concerns, and is databases can and do evolve to render older platforms obsolete. And this reality frightens those of us now using older EMRs and lab databases. How can users of the quite complex interactive systems discussed can assure that we'll seamlessly survive and not die and not become obsolete, I presume? So Dimitri, if you want to start.
Yes, well, if it comes to the cell phone, it's always good to have multiple systems informing you about an alarm. So you don't just rely on one system. You always need a backup system, because if one fails, you obviously have the other one. And indeed, for the time being, probably most systems still use an analog line, because that's the other alternative. And I think it's the same that holds true for also computer systems, I guess. I'm interested in how other people think about it.
Yeah, we have a phrase in the UK, we call it belt and braces. I don't know how well it translates, but to have a plan B is always a good idea. But you know, deciding on where the data is stored, how it's being backed up. Just today on this webinar, I've got an Ethernet link to Zoom, but I've also got a Wi-Fi backup. And we tested it earlier, and you wouldn't even notice if I pulled the plug out. I'd just carry on going. So I think you have to validate the systems that are being implemented. But once you've reached that validated state and you've been able to maintain it, you can actually develop systems that are far more robust in terms of securing the data and being able to notify and alert and provide proactive alarms than any other type of system. It's just making sure that you've implemented them correctly and validated them correctly. And that's partly down to the responsibility of the developers as well.
I agree. I think that the more important, the more relevant the potential mistake, the more relevant having redundancy. And I have a question for you, Matt, before we move into the next one, the survival of the old applications and systems. How much do you feel that humans can over-rely on electronic systems? Let's say the witnessing system. Then, okay, it's Sunday, let's not bring a cycle embryologist for double check. We have the electronic system. And then the one embryologist that was supposed to read the tag just tells that everything is fine. How much do you think that this could happen?
Absolutely, it is a risk. It's part of our risk assessment as developers to avoid what's known as automation complacency. If you're too heavily reliant on an automated system to replace the human, if that automated system gets something wrong, then the human needs to be able to know that the system's got something wrong, or if something comes into a work area that shouldn't be there, the system needs to automatically say that. But if the system fails, how do you know that there's something in the work area that shouldn't be there? So I think there needs to be a happy balance between human interaction with the electronic systems. I'm always quite careful to use the term automated systems, because not all electronic systems are fully automated. We would actually design our systems, for instance, to avoid a fully automated solution for that reason. What we're trying to do is implement a system that engages with the human factors that we're all vulnerable to. So an electronic system needs to interact with the human as well. And I think Dr. Sable also made a very good point about standard operating procedures. So if you talk to any airline pilot and say, what's the most important piece of equipment that you're using in the cockpit, it will not be the autopilot. It will be the standard operating procedure that they're applying. Part of that system happens to be autopilot, but it's not the only part of the system. So I think you need to be aware of that. We need to develop systems with ergonomics and human factors very much in mind. And that's why it's a fantastic question. Yeah. Hopefully that answered that question.
Yeah, absolutely. I mean, at first I thought that I was the only one that was concerned about this automation complacency when applying for CE mark, but I'm happy that I'm not the only one concerned about that. And to everyone, I guess, what do you think about, I mean, we have to accept that software will evolve and new software, new versions will render the previous ones obsolete, but how much is acceptable? What can be done to make sure that these ones will move forward, survive, or at least become compatible with future softwares? Any Matt, you are the developer, so if you want.
Yeah, I think, I mean, again, we use another phrase. Sometimes you've just got to let go of the side of the pool. You know, we're obviously concerned about future-proofing the systems that we develop and improving and updating the systems. And there is an obvious thought that our backup plan is always to have a manual-based system, because we can always revert back to paper-based manual systems. I would actually disagree with that. I think the time now is to let go of the pool. If you use the analogy that I used in my presentation about your distance to empty warning light, you're not continuously checking the level of your fuel every morning with a dipstick anymore. You don't need to do that. The electronic automated systems can completely replace the human systems, I think, and they will continue to evolve and develop. But just in the same way that you know, any of the big players like Microsoft or Apple or whoever's developing the software has to bear in mind that it has to be backwards compatible with things that have come before. Okay, floppy disks are not used anymore, but there is perfectly viable alternatives which have replaced the floppy disk, and that's exactly the way that we continue to develop. I think you've just got to be brave and let go of the side of the pool.
Yeah.
And yes, let the manual paper-based systems die.
Yeah.
Slightly controversial for me to say that, but I really think we've gone way beyond the point where anybody who is using manual paper-based systems for electronic medical record keeping, for instance, it's slightly absurd. Anybody who is handwriting information on a cryo device is also absurd. If you take a step back and look at the danger and the risks associated with that, yeah, we have to move forward.
I mean, Unika, I don't know about your experience, but for our embryologists, switching from handwriting to the reflections app, for example, it was just like teaching them how to write on the clipboards. It was straightforward. So I think that the evolution is just going to happen. We just have to make sure as developers that we anticipate that we can incorporate older software and to organize with other companies in the hope that we will be able to share data that IVF clinics will open, and this will hopefully allow us to start thinking about using machine learning for big data, because I do think that the learning that can be done currently is very shallow, and until we all as IVF centers, as developers, organize, get together, get the patients on board as well, and understand that all this information sharing is to the best of the benefit of future patients and probably themselves, that's when we're really going to make machine learning work for everybody.
Very quickly, lightning round, yes, no question. Matt, Dimitri, Unika, it's 2035, we're doing 20 million cycles IVF a year. Single embryologist sits centrally, oversees several thousand IVF cycles from hundreds of miles away concurrently. Yes, no. Matt?
Yes.
Dimitri? Nika?
Yes.
Okay,
2035.
one more. A company comes along, wants to find new practice standards, takes every piece of information from the 10 biggest IVF cycles centers in the world, feeds them into a tremendous computer that churns through all the data, finds out using machine learning and AI, all sorts of new protocols that we never would have figured out because we're not smart enough to look. Matt, yes or no?
Yes.
Dimitri? Nika?
With validation,
Okay,
possibly yes.
I'll stop there.
Okay.
Okay.
Well, I think it's time to thank you all for being here. thank you, I3, for hosting this webinar. David, great co-moderator as always, and nice to see you. And last, of course, thank you to our sponsors today. I am Dimitri, SealSpeaks, and thank you for today.
Great.
Thank you very much.
Thank you.
The organizing committee, Jacques Cohen, Peter Nagy, Giles Palmer, Thomas Elliott, Mary Ann Chavez-Badiola, and Shasta Sandrudan. Next week's session, same week, same back channel. Again, about lab management, this time with a bit of a twist. The Facebook group Maverick Reproductive Biologists take siege on I3 and put on their own show. Have a good day and thank you again.
Thank you.
Bye-bye.
Bye-bye.